Okay, returning to our four-stroke cycle, we've covered the intake stroke, we've covered the compression stroke. Now we're going to take a look at our next stroke, which is actually called the power stroke. All right, so we have, we'll draw our cylinder again. We have our cylinder walls. Okay, inside the cylinder, we're going to have our piston. Our piston is now at the very top of the stroke. Again, if you remember, this is called TDC, top dead center. And again, where the piston was before down here was called BDC, which is bottom dead center. So right now the piston is as high up as it can go. Again, above the piston, we have two valves. Okay, one valve here, one valve here. Okay, this is our intake valve. This is our exhaust, EXH, exhaust valve, intake valve. Now, during the end of the compression stroke, piston was coming up, both valves were closed. We took all that air and fuel that we pulled into the cylinder and squeezed it into a little area right here. Again, we talked about the compression ratio. So let's call that, we took 10 parts of air and fuel and squeezed it into one. So we're going to call this a 10-to-1 compression ratio. Compression ratio. And again, a lot of cars are between 9-to-1 to some are over 11-to-1, depending on the engine. So that determines how much power that engine can generate. If you have a high compression engine and use premium gasoline in it, it will actually create a lot of power compared to a lower compression engine using regular fuel. All right, at this point, at the top of the compression stroke, we're going to start the power stroke. Now, in between the two valves, we're going to have a spark plug. Oh, by the way, here's a gasket for a cylinder head, so you can see what it looks like. Actually, I can show you another one here. This is actually what a gasket looks like on a four-cylinder engine. So you can see they're similar. It's made out of steel or some other material that can squish when you tighten the cylinder head on. So this is a gasket for this engine, and this is for a four-cylinder. If you have an 8-cylinder, you'll have two of these, one on each side, because it's a V-type engine. You'll have 4 on each side. If you have a straight 6 engine, you'll have another 2 cylinders over here, so you'll have a longer gasket. So that's what the gasket looks like. And again, that seals between the cylinder head where your valves are and your block, which is where your piston is located, your cylinder. All right, during the power stroke, both valves are still closed. So we're just going to make a note here that this one's closed, still closed, this one's still closed. So in between the two valves, we're going to have what we call a spark plug. So here's your spark plug. This is going to have high voltage going to it. Now, in the small engine, we're going to use this right here. Let's call this a coil. This is an ignition coil. It's basically going to generate a high voltage and send it down this wire, and we're going to plug our spark plug into this. And this is going to be mounted inside the cylinder head in between the two valves. Now, when the spark is needed, it's going to make a spark across the tip of the spark plug. So I'm going to draw up on our picture here, in between these two valves, we're going to put a little tip of a spark plug. So this thing here is our spark plug. Now what the spark plug does is it allows the energy from this coil to travel down through the center of the spark plug till it gets to the very end, and then it wants to get to to metal. And this little tip that sticks out of the bottom of the spark plug, which is called an electrode, this is a side electrode, that's a center electrode, is going to make a spark going across these two. So there's going to be a spark jumping across these two surfaces here. We'll make it blue. Okay. Blue spark is the strongest, pretty much purplish blue spark is a high voltage spark. Orange sparks are more lower voltage. White sparks are even hotter. That'd be like a lightning bolt. But most sparks that you'll see in a car or small engine will be orange to purplish, bluish. And that would be in the thousands of volts. That would be like between 5 and let's say 30,000 volts on a small engine. Car engines can go as high as 100,000 volts. But picture this happening. This is going to make a spark within our combustion chamber where our air and fuel is squished. That's going to ignite the air and fuel in that cylinder. So what happens coming out of here, we're going to have a wave of heat generated by that spark lighting up the fuel. Because the heat expands the air, it's going to push the piston down. The heat from that air expansion is going to push the piston down. And that's going to allow our engine to create power. That's how our power is made. So as the piston gets shoved down by this air and fuel expansion, rapid expansion, it's going to cause the crankshaft, which is down here, to spin because the connecting rod is connected to this and it causes this to rotate. So that's going to actually create energy for our engine to spin. Piston's going to get pushed all the way down to the bottom, eventually making it down the bottom dead center again. So piston's going to end up down here and the end of the power stroke. Okay, next stroke we're going to have, once we finish the power stroke, let's just erase this real quick. Okay, the last stroke is called the exhaust stroke. Okay, now this stroke, exhaust stroke, we're going to make our cylinder bore. Here's our cylinder bore. Piston is now all the way at the bottom now of the stroke again, bottom dead center. Bottom dead center basically is as far down as the piston will travel. And this is actually where the end of the power stroke is. Now, basically what we did was all the air and fuel that were in that cylinder are burned away. So inside, I'm just going to put a whole bunch of black dots in here. This all represents exhaust. And that's because most of the air and fuel are going to burn. Now above the cylinder bore, you're going to have, again, your two valves. You have one valve located here. You have your other valve here. The larger one's the intake valve. This is the exhaust valve. Now, the intake valve is still closed from the power stroke. The exhaust valve is now going to open. So we're going to write here, this is going to open up. This one here is still closed. And basically what's going to happen is as the piston travels upward during the exhaust stroke, it's going to allow all the exhaust that was trapped inside here to come out through the exhaust valve. So picture all this exhaust being able to travel past the exhaust valve. We're going to quiet it down using a muffler. So here's a muffler on the small engine. So you can see this is basically mounted over here somewhere. So as the exhaust comes out, this does two things. It quiets it and also keeps a flame from shooting out of the engine, because without this, there will actually be a physical flame coming out of here, and that's probably not safe. Might look cool, but it could be a problem. So right here would be some kind of muffler. Now, as the piston travels up, it's going to just force all the air, all the burnt air and fuel, which again is our exhaust, out the muffler and then into the air. Till the piston gets to the top again. Again, we call that top dead center, TDC. And that's the end of the exhaust stroke. When the piston gets to the top here from the bottom, that's your end of your exhaust stroke. And then the whole process starts over again. So we're going to have intake, compression, power, exhaust. Just kind of keeps repeating itself over and over again. All right, so that's basically the 4-stroke cycle. Just to review real quick. So during the first stroke, we said was the intake stroke. Our piston would start at top dead center, and intake valve would be open now, exhaust valve would be closed, and we're going to pull the air and fuel in as the piston comes down. When the piston gets to the bottom, we're going to go into the compression stroke. We close the intake valve, we keep the exhaust valve closed, we squeeze all that air and fuel, and we said we need to have the right ratio of air to fuel in there. When the piston gets to the top, it's going to have the spark plug in between here, and we said that the spark plug is going to ignite the air and fuel to get compressed. That's called the power stroke. That's going to force the piston down because of the heat expansion. And then at the very end, when the piston's towards the bottom, it's going to want to push out all the used up air and fuel that burned, which is called exhaust. By opening up the exhaust valve, we're going to force that out through the muffler into the air. And then it just keeps repeating itself over and over and over again. And this happens really quick, so you can't even like visualize. When somebody says my engine's running at like, let's just say 5,000 RPM. RPM is rotations per minute. Let's make it easy here. Let's make it 6,000 RPM. Just to give you a visualization of what's going on here. This is rotations per minute. So the crankshaft is spinning 6,000 times in a minute. So picture this thing spinning around that fast. Now, if we divide 60 into that, that would be 100. That's 100 rotations per second. So that means that when the engine's running at 6,000 RPM, this crankshaft is spinning 100 times every second. So just picture that, set, boom, 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 the thing's flying. That means the piston's also traveling up and down that fast. So you can understand why things have to be lubricated properly, things have to be pretty strong. Connecting rod is really kind of a weak spot in this engine. I can show you some disasters that I have. Here's a disaster right here. I have some with the little engines too, because I've had, over the years, I've had students start their engine up and didn't do it right, and the connecting rod just broke right in the center in 2 pieces, because in the small engine, the connecting rod is made out of aluminum. So it's not really that strong, but if there's a problem, usually the connecting rod, if you over rev the engine, let's say your engine doesn't, let's say you have a tachometer in your car. If you have a tachometer in your car, it'll look something like this. So you might have RPM written on it, and it might have like a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9 times. In this case, it'd be times 100, no, 1,000, times 1,000. So what they're basically saying is 1 isn't 1, it's 1,000, 2,000, 3,000, 4,000, 5,000. So let's say this is where your needle is right now. Let's say you're driving along and you're right here. Your engine is running at 4,000 RPM. If you see your tach, this is called a tachometer, and just call it a tach. Not all cars have tachometers, mostly used in cars with stick shifts, but I've seen a lot of these in cars with automatics now. Other than you knowing how fast your engine is, it really doesn't help you with driving an automatic car. If you have a manual transmission, it can actually help you determine when you want to upshift and downshift, but people like to see how fast their engine's going. This is not a speedometer. Speedometer's miles per hour. This is engine rotation. Now, in this area on a lot of cars, you'll actually have, I don't have an orange marker here, but let's make this area here all red, right here. So this is all like red, kind of red, and then this little area right here is orange, and everything else up to that is, you know, no color. What that means is if you rev your engine so fast that it gets into the orange area, you're risking caution. Basically, orange is caution. If you rev it all the way up into this area, let's say you're at 7 or 8,000 and you're in that red area, which your engine might achieve, you might actually break something in your engine. And usually the weak spot is the connecting rod. So I've seen cars where the connecting rod breaks and the piston comes right out of the engine, goes right through the hood and comes flying out of the side of the engine block. So when it says the red area, you don't want to rev your engine into that area. Your engine has to be built strong. They sell different types of connecting rods made out of different material. Like this one here is bent too. That other one really got twisted. I don't know what happened. That was an engine I took apart a long time ago. I saved this stuff. Aluminum connecting rod isn't used in a car engine. This would not be strong enough for a car engine. You'd snap this thing pretty easily. They even sell connecting rods made out of titanium, which is like engines that can rev like 9 or 10,000 RPM. But you have to build the engine to withstand that. Also, people like throwing superchargers and turbochargers on engines. You need to build the bottom end of your engine to handle that kind of pressure. Because basically what you're doing with a turbocharger or a supercharger is on a normally aspirated engine, which is what we've just been discussing, the air and fuel is drawn in just by the piston moving down. It's basically using atmospheric pressure to push the air in and a little suction as the piston comes down. So it kind of pulls the air and fuel in. When you have a supercharged or a turbocharged engine, you're actually pressurizing the air and fuel on the outside and pushing it into the cylinder. And you're boosting the pressure maybe as much as 10 psi, pounds per square inch, into that cylinder, which means everything below it has to be stronger to withstand that extra pressure you're putting on it. So that can actually cause damage to your engine if it's not built to withstand that extra pressure. All right, so that's a little about the tachometer, a little about the orange and the red area of a tachometer. You can see that on cars. And again, the 4-stroke cycle. All right, that's basically it for this. So I made a 2-part.